All right, we're live.
We are live. Let's see here. Thank you for tuning in to the Secure Your Energy Show, where we'll have real life conversations with real life people. Our show explores the solar and energy storage market. I'm your host, Michael Gibson, and my company is Fortress Power. Fortress Power, we are a lithium battery manufacturer located outside of Philadelphia, where we focus on the life pole technology. Today, we're going to have a wonderful show. We have a guest. His name is Eric. He is our Chief Technology Officer here with Fortress Power. I'm going to bring him on. He can introduce himself and he can just tell us a little bit about his history and how he got into energy storage. So let me bring him on right now. Eric, introduce yourself to the guest for me, please.
Hello, everybody. So my name is Eric. So I've been working in the most of the time in the past 17 years is in the automotive industry, and some years in the energy. So my major was the chemical engineer. So the battery chemical things becomes one of the my uh, my super interest in the past 5 years, particularly with the electrification progress in the world. So the battery becomes a major important role in this whole revolutions.
Eric, electrification, that's a pretty big word. I mean, that's a very big word. So that's going to be the first topic we talk about today. We're going to talk about electrification, and hopefully Eric can break that down for us common folk, as I like to say, to educate us on what that word electrification is, what it means. And again, this is just a casual conversation, so you get to see some intimate talks between Eric and I, and engage with us, comment to us, let us know how we're doing, what we could do better. And again, thank you for tuning in. And I'm going to turn it over to Eric. Would you like me to pull up your slide to talk about electrification?
Right. Maybe we'll take out one slide. So we try now to show too many slides. We want to do more interactive with you. If you have any comment questions, as Michael just mentioned, please bring it up. We'll try to answer as much as we can. We can look at the first slide. So I don't want to show too much about the statistic, but that, that the chart just shows a tremendous growth on the uh, battery demand in the world and the energy, particularly in the energy storage side. So you think about the people always think about, all right, so we need a lot of batteries, and then why and so on. So it's actually not because of a battery, it's because of the world going to the time of we see electrification. It doesn't mean how many people get access to the electric. That's already the in the past. So we're talking about the electric. We use electric for everything. So we thought about like electric car, right? That's not something brand new. I mean, somebody think about it like 100 years ago when the electric come up, just some of the problem they couldn't solve, right? The range is too short. You don't have a nice place or a way to save your energy in and use it in the car and so on. So the battery, particularly the lithium battery, exactly solve this problem. So it has everything we need as an engineer. We can think about it, right? So the raw material, lithium, or those chemical into the battery is widely available. Right? So it's all over the place. We don't have a limited limit. We don't have any, almost have no limit. You can recycle it. You can get access. You can get it from the ocean. You can get it from the mining. I mean, it's not like oil, and then you take some out of the ground, and then you lose some. So there's only reservation under the ground. But for the battery side, lithium, all those chemicals are widely available. That's number one. Second is you always easy to process those materials. And then third is we always can, we already can project, we can have a good engineer way to make this things dirt cheap. So all those three things becomes cheaper, right? So we want the performance and the cheaper material to be used for the industrial. That's what we call the electrification. Right? So now you can look at it, even my headset or where it is as the lithium battery in it, and your car, right? So Tesla is doing job, Ford is doing that. Everybody's doing the electric car now because the battery performance will support this. And then that's what we look at every day. But if you come up one step into the industrial level, so you look at those modern machining, right? So people get rid of a traditional hydraulic system already. They all use the electric motors control. And then all those manufacturing environment, that's all robot, all driven by the electric. So everything go for the electrification. That's what we call it. And then the lithium battery is the right material in this area will solve the major problem for energy storage. So that's the major element. That's why lithium battery demand will be skyrocket in the next 20 or 30 years and continue going this trend.
So let me ask a question, Eric. When you say world electrification and you mentioned electric vehicles. As a consumer, what is the difference you would say between electric vehicle battery and then the energy storage battery? Could you speak on that?
Yeah. So the so in the lithium battery, we call the lithium ion battery in general. That's a very broad, let's say, very broad definition. So I cannot count with my hand with all kind of different lithium chemistry in the world. So when we choose something for the car, so the performance is important. So the performance means we want a certain energy density, and then we want also the power density as well. So that means the battery you typically design into the car, you want the lightweight and the high energy can store in the specific cubic space. So that's what we would design for the car. And then you want that the charge rate and discharge rate is higher, and there's certain things on the pack design as well. But when we come to the energy storage, so the safety becomes first important, and then the space becomes less important. And then we want to look at the cycle time. So you want to say the energy storage is there and use it for every day. And then it's almost like 18 hours a day, the battery is charging and discharging. You want to have a long life cycles, which is not the case for the car. Car usually you drive for a while and then you park there. I would say 90% of people commute is drive there, park there, and then they drive back. So the daily mileage is less than 100 miles. And then most of the time, the battery is sitting there and then resting. So that's totally different concept applications. So on the car side, so we choose the lighter and the high energy density and the high power output input for short time period. And then for the energy storage, we choose something safety first, and then give you really long lifespan performance. And then that's the chemistry we engineer into when we do the energy storage project.
So when it comes to lithium battery technology, are there different chemistries? Are there different aspects? Are all lithium batteries created equal, so to speak? Is there a delineation? Can you speak on that?
Okay, I can talk about it from two perspectives. So we'll see the one from the battery chemistry. The other we'll talk about the manufacture processes. So the it's funny. So I count. I cannot remember all of them, but I can count at least 5 or 6 of them. So you have a LiPo, right? So you have a NCA, so which is a nickel cobalt aluminum oxidized, and then you have a LCO, lithium cobalt oxidized, and you have the LFP, so lithium phosphate. Then you have the NMCs, which is a nickel cobalt manganese oxidized, and then you have also the other kind of battery chemistry. They all called lithium battery. So the most popular one I've seen is NMC, right? That's very popular in the automotive industry. So that's what the Tesla battery are. So that's the material has high energy density, and then has a little bit shorter lifespan. Then we have a little bit concern on the safety on those chemistry. Lithium phosphate is has less energy density, but it's a little bit very good, let's say, safety performance, and then has a very long lifespan, and very tolerable for temperature as well, right? And then for the other, like the lipo, right? That's another thing. So lithium polymer, that's you use we see it's very common. We use it for the consumer electronic, right? That's all the materials we look at it. And there's also LMO, so lithium manganese oxides. That's you see in your a lot of power tool use that battery because you give a good output, power output in a short time period. So all those are different chemistries in the lithium batteries.
So each chemistry inside of the lithium family does serve a different purpose. Now, I know
Right,
we had a slide show. I just want to bring up the slide so people out there in the audience can kind of understand, what we're talking about. So I'm gonna bring this up so they can see exactly what we're referring to here.
right. So that's what just I mentioned. So like LMO, NMC, LP. So that's going to the different areas. So some for car, like NMC, is perfect because theoretically the energy density is higher, and plus the manufacturer processes. I mean, I have a funny car there, but it's all electric. It's perfect for the car applications. LLP is just perfect for the energy storage. If you see something at home, you want to be safe, and then you want a long life cycle. You want to swap out every 3 years. So that's it, going to be sitting there for 10 years, and then throw out a good amount of power for you. That's all the differences. And then the on the other side, I just mentioned that. So in the manufacturing processes, a lot of people ask, what about the prismatic cell? What about the cylindrical cell? What about this and that? So it all has a pros and cons. So it's really, you have, as an engineer, we have to consider systematically, right? How do you choose the cell? What shape of a shell you choose? And then how do you design in the system? What about control system? And we also look at the manufacture processes, right? Is that something 100% trackable? We know exactly what's happened. And then everything need to be under control. You just need to make sure the 1,000 different elements going to the manufacturer and the final product is under control, and then you can deliver high quality product.
So let me ask, what technology is used in the Fortress Power battery? Considering that this is a Secure Your Energy
Right.
show, so we have an opportunity to discuss some of the things that we have and the technology that we use. What technology is in the Fortress battery?
We only use lithium phosphate because the safety concern. So for the energy storage engineer, right? So we design the battery, no matter it's battery or capacitor. So the first coming to the mind is safety. Second is safety. Third is safety too. Safety is the most important. So from the cell, even I said that that's only one element going into the final product, and it's a very important element. It's take up 30-40% of the risk concern. But that's where we choose the lithium phosphate as a basic material. And we also customize compound a little bit, right? So to make them more safer, and also targeting for the little longer lifespan. So that's what we design into lithium phosphate chemistry, with our specific compound is the material we choose to put in our battery pack.
Now I hear a lot of people talking about, the NMC, nickel magnesium cobalt technology versus the
Yeah.
lithium phosphate technology. What are some of the differences that a consumer would need to know between the two technologies? Because they seem to be the two formidable ones out there that the lion's share of our competitors go to market with. What are some of
Right.
those differences? What separates lithium phosphate from nickel magnesium cobalt?
Okay. So the NMC material is we show in the last slide actually the NMC material has very good theoretical energy density. So it's the highest, right? And then compare uh, in the manufacturer or business decision. So you want to have a theoretically higher energy density, And the individual cell also have a higher voltage, right? So it's a 3.7 volt instead of lithium phosphate 3.2 volt for each cell. Then the voltage also determine when you design the system, you can reduce a good amount of for example, your cable sizes, right? So you can use a smaller sizes to deliver the same power. That's come with the electric law, and all the other surrounding electric stuffs, electric components, you can undersize it and save the cost. For the car manufacturers, that's what they want. They want to reduce the cost and they want to reduce the weight, and they want to have a high energy density. So that's why NMC has a perfect, let's say, sweet spot for them. In addition, so the NMC in general, in the old, when they make the battery, there's just a good way they can make it cheaper, right? That's why it is going to the car a lot. Uh, there's a concern on it is the safety. So we can see the chart, the safety is a concern. A lot of people said that yeah, it's because it has let's say it has the flame material in it, and then the temperature catch fire is lower. It's because when you use the battery, the NFC material actually during the chemical reaction, it generates a little bit of oxygen, and then plus it heat up itself, and plus it has the flammable materials in it, cobalt, those things. And once you have once the design fail or the you have external pressure, then the system is going to short and it's going to catch fire, because when you catch fire, you need two things at least. You need oxygen and you need the you need the flammable materials. So the NMC materials just have both of them. And then on the other side, the LLP just doesn't have these issues in the chemical reaction. So even you get a really bad situation, you will just get smoke up, right? So we really don't see too much concern on the cell individually. We see it will catch fire, particularly when we do the safety testing on UL. So that's all the statistic. And then from theoretically and from practically, we all see that the LP is something safer, and the MC has a potential risk. I'm not saying it's a must be. It has potential risk. The risk is higher. So when we design a product, I choose the risk lower, especially for something I care the most, the safety for the customer. So the lowest risk is the better for me. So the NMC is never on our radar to be a energy storage product. But if I'm automotive industry, the NMC becomes most important for me, because it just improve my end customer experience, because it carries more energy and go long range, and then it's relatively smaller and it's easy design, and cost for us is low. So it's just a different perspective of choosing different materials.
So as a homeowner, I think that one of the points that jump out to me is the cycles
Right.
between the life cycles between the two technologies. Could you speak on
Right.
that? What do you see as the major differences in life cycles between NMC technology versus the phosphate technology?
Right. Yeah. Phosphate is just has a long lifespan than the NMC. There's some marketing things in the market might cause confusion, because Tesla will see 100,000 cycles or something, lifelong car. In principle, just theoretically, the NMC life cycle, you won't be able to be better than the LLP. LLP materials, just their structure, the way they do it, I mean, how the theoretical calculation on those, this has just double the life cycle of what the NMC can provide. So that's just the statistic analysis with the theoretical design. So life cycle LP definitely is the best at this moment. I mean, there's the other battery like LTO battery, but they're super expensive. But just in the most production batteries, LP has the longest life cycles.
So would you say that if I was trying to compare cost between the batteries, I know generally speaking, a lot of the manufacturers they post about 6,000 cycles for the LFP technology
Mm-hmm.
versus 2,500 to 3,000 cycles for the MNC
Right.
technology. So to the consumer, and you're trying to do a cost benefit analysis,
Right.
is it safe to say that the LFP technology is going to approximately last you twice as many cycles as the NMC? Is that a fair statement to make?
I, I think so. Yeah. The cycles means you get more energy out of the battery pack. The NMC it just has less cycles. And a lot of the MC chemistry, when they design the system, so they only allow you to discharge at a certain kW, right? You don't even reach to zero point 0.3 or 0.4 C. And then your power output from the battery is slower. And then the way you use it, they only give you around about 75%, right, the energy or less. So that's how they control their cycles. On the other side, the lithium battery, lithium phosphate, then you can do energy output a little bit quicker, right? We usually allow you half C, 0.5 C, or a little bit higher, maybe on the specific situation, and then you can charge and discharge a little bit more in depth, right? It's 80%, sometimes go 85% up and down. So during the long life cycle, if a 6,000 cycle calculation, you'll get a much more power from one lithium phosphate battery pack than the NMC pack. So that's why you get a much more benefit from on the money side. So there's where you save a lot of money, just choose the lithium phosphate materials.
Now, I know the majority of our conversations we were talking about, lithium battery technology, but there is the old school battery, the lead
Right.
acid batteries. Now,
Yeah.
with the lead acid batteries, you mentioned something about discharge rate. What is the difference, the major difference you would say between the flooded lead acid gel type battery technology when it comes to discharge rate versus lithium technology? Why would a consumer that has been using lead acid, they're very comfortable with it, they like it, why would they now want to go to lithium technology? What are your thoughts on that?
Yeah, we spent ever since we started the promote the our technology, so the energy storage battery 5 years ago. We did a lot of time to educate the installer and the customer. So we did a lot of blog to talk about it. So it's not because people like lead acid battery. It's just because at that time you only have lead acid. And then I can tell lead acid battery is still going to continue for another 20, 30 years because it has it's a specific application and goals. And so nobody's gonna put a lithium battery in the car for start of a car or use just some light bulbs and so on. So those applications still exist. And then it's cheap and it's easy. So people can spend like $100 and swap out their car battery. If you choose the lithium batteries, there's going to be double, triple the price. But when we talk about a lot of the home energy storage off-grid system, and then the lithium battery is head and shoulder better than the lead acid. I mean, charge rate, what you mentioned, higher, right? Discharge is higher. Type of discharge, you can do much more. So lead acid, you only can do 50%. Usually, if you buy 10 kilowatt hours lead acid, you only can use 5 kilowatt hours. If you buy 10 kilowatt hours lithium phosphate battery, you can do theoretically you can do 100% depth discharge.
And
So
what
has no
about,
problem.
is there a maintenance difference between the two technologies? If I already have an existing battery bank at my house and
Yeah.
I'm used to lead assets, what type of maintenance difference is there between the flooded lead acid and the lithium technology? Is there a difference?
There are quite a bit of differences. So lead acid has multiple different technologies, traditional, right? So and then they have AGM, improved performance one. Uh, some of them are maintenance free, but in general, lead acid, when you do the installation, you need to have a ventilation system. That's a requirement from code. So you need to vent the potential hazard gas out. So you need ventilation. Lithium cell is fully concealed. Nothing come out of it, nothing go into it. So you don't need anything. It's just like your AAA battery. Use it and charge it. And the uh, traditional lead acid battery, you need to do the equalization periodically, right, to tune up the performance. Let the chemical react a little bit more uh, after certain cycles. Uh, you don't have to do that in the lithium battery. And then the lead acid, some of the lead acid you have to fill in with water periodically, but that's it's older style. But then lithium you don't need to do anything. So lithium is a maintenance free. You put it in there, install it correctly, it's gonna last long. And lead acid you're gonna go back periodically, just like the car. You have to internal combustion car, you have to change oil, change this. It's just multiple things you have to keep yourself on the routine. And their performance is not see per cycle, right? Per kilowatt hours is actually it's more expensive than the lithium battery now.
That's big. So you're saying that when we're looking at these different battery technologies, that lithium technology is maintenance free compared to your traditional old school technology that still has this place. So it
Right.
has this place. It has a higher depths of discharge in comparison to your acid batteries, and also it has a larger cycle life. So to me, if I was a consumer, if I was a homeowner looking to put energy storage or add that to my house, it seems like a no-brainer almost to go with something that's going to be less maintenance, that's going to be safer, that's going to have a greater depth of discharge, and in addition, just a longer lifespan. So
Yes.
I can see why the lithium technology is kind of taking off. So we have a few minutes left.
Yeah.
In our energy show broadcast today. I want to talk about the last topic that we talked about, and it was just safety. I know you
Yeah.
had a slide on that, so I'm gonna just bring up that slide so you can just kind of talk to it. It's the last slide that we're gonna bring up today.
Yeah. Cool. So safety, and safety. So that's the only things, or the not the only thing. That's the first priority when we design our products. Nothing beyond that. Safety. Second is reliability, and then we consider performance too. Uh, so what I mean, the safety is not only about the you choose the cell correctly, and it's about the cell chemistry, how you choose it, and then how you design it, and where you want to go. You want to balance out the good amount of the life cycles, and also the power output. And you also want to consider the temperature tolerances. That's where we put consideration in the cell selection. And then we come into the battery pack design. How do you manage your thermal performance? How do you want the heat out? And how do you make the battery pack higher IP rating? So that's the second consideration for us. And the third is the battery management system. It is important. It's not the big portion of the battery pack. It's only PCB board with embedded computer, but it manages your battery, keep your battery safe. Yeah, that's very important. So a lot of people talk about, all right, BMS is going to make the battery life longer and so on. That's the secondary consideration. The first consideration is you monitor every single movement in your battery, make sure the battery react, or make sure the circuit react to when battery has risk to catch any safety issues. The last one, most important, we have the whole bunch of a quality guy, right? What they do is they look at the manufacturer. They're going to the manufacturer, they audit and they check everything, make sure every single components go on our products are trackable, come in with high quality, come out with perfect inspection. So that's four elements going together to make sure high quality and high reliability products.
So you said four elements. Let's go through them again. Restate that for everybody while I have the slide up. What are the four elements that goes into making it safety? Just reiterate that for the audience. I wanted to have the slide up so you can say it.
Right. So that's the battery cell chemistry choose, how do you choose it, and the battery pack design, and then your management system of the battery, how that performs, and then you want to fully control manufacture processes. So that's the four elements to make good product.
Well, thank you, Eric. You've been a wonderful guest. Time has flown by quicker than I thought, but I
Right.
thank you for taking time out of your schedule just to hop on and to discuss some of the things going on in the lithium battery technology, the battery safety. I really appreciate it. Is there any parting words that you would like to share for this broadcast today?
Okay. So the yeah, I do have some. So first of all, thank you for having me. Second, and most important, so New technology is coming at us, so don't worry about it. Take it, they're good. So the electrification progress in the world is definitely going forward very much. It's good for the environment, good for the industry, good for everything. Particularly the energy electric we get almost free from the sun. And then the battery, lithium battery technology come with it becomes a major important role. If the you're still using the older technology for energy storage, so don't worry about the switch to the lithium battery. We'll help you, we'll support you for design. It's I can promise you, it's much easier than you install a traditional battery chemistry.
Well, thanks again, Eric, for taking time out your schedule to come on to be a guest on the Secure Your Energy show. I'm pretty sure that we will have you back because there
Sure.
is a lot more things to talk about when it comes to lithium battery technology and
Right.
energy storage. So the last question that I want to ask you, because on this show, in this conversation, this intimate look into securing your energy, why did you specifically get into the energy storage market? This is going to be the last question that I have for you. What made you to decide that this was good for you?
Yeah. So the the number one thing is I come out of the chemical engineer background, so my school is pretty good at the battery technologies. That's what I has been educated for let's say continuous like bachelor and the master. I have a good understanding on this, and then the most important thing is I see sustainable energy development in the world are so fast. It's really going to save us and save the earth. We see the wildfire happening, earthquake, and then the temperature going up year over year. I don't see the snow anymore like when I was a kid. So we need to utilize renewable energy, right, to boost this world. And the lithium battery with energy storage is gonna be the most important things in every home or every energy, every PV system. But that's gonna save us uh, a lot of CO2, right? And it's going to save the whole Earth. So I truly believe this is the goal and this is the target we should achieve. It's not only for a company, I mean, so company will support this. It's only for individual person, individual family, anybody want to achieve the green goal. So that's where to go.
That's awesome. I thank you again for just sharing your thoughts on lithium technology and even why you got into this. But again, thank you to everybody that has viewed this. If this information, you have enjoyed it, you want to see more of it, definitely email us at sales@fortresspower.com and send us a topic if there's something that you want to discuss. If you want to be a guest on our show, send an email, just type in Secure Your Energy Show. And I'm going to let Eric go. And thank you, Eric, for being a guest on the show. I greatly appreciate it. And I am your host, Michael Gibson, and you have been watching the Secure Your Energy show. This is our opportunity just to have a conversation to talk about things going on in the solar and energy storage market. As I stated before, if you would like to be a guest on our show, please send us an email at sales@fortresspower.com with the subject Secure Your Energy. We thank you. You've been a wonderful audience, and we would like for you to like, tag, share, and invite. Thank you, everyone. Enjoy your day.
Thank you.